Michio Kaku reveals insight into a surprising revelation. The James Webb Space Telescope has recognized a disturbing signal transmitting from the Andromeda cosmic system for over a century. Our understanding of Andromeda was generally terrestrial, but at this point, outfitted with the James Webb Space Telescope, our perspectives are decisively shifting. This new information has sent shockwaves through the scientific community. But what does this stunning revelation tell us, and why is it creating such a ruckus? Before we get into the specifics of the alarming signal, it's important to understand some background on the Andromeda Galaxy. The Andromeda Galaxy provided the first hint that our universe extends beyond the Milky Way. This revelation shifted our understanding, highlighting that we may be just a small piece of a vast universe. At first, the Milky Way was seen as the center of the universe. The real game-changer came with Edwin Hubble in the 19th and 20th centuries. Using the Hubble telescope, he noticed distant objects beyond the Milky Way, identifying these. 1 minute and 3 seconds. Early cosmologists could not separate the Milky Way into individual stars due to limited technology. However, this changed with Galileo Galilei in the 17th century. This finding began to challenge the idea that the Milky Way was the only world in the universe. 1 minute and 37 seconds. As astronomers discovered separate galaxies, our view of the universe expanded. One of these galaxies was Andromeda, also known as M31. Its observation dates back to the Persian astronomer Abd al-Rahman al-Sufi in the 10th century, who noted it without the aid of telescopic technology. By the 20th century, technological advancements allowed astronomers to explore further. They realized that Andromeda was not just an indistinct cloud but a vast universe of its own. 2 minutes and 13 seconds. Since then, observations have shifted from ground-based telescopes to space observatories like Hubble and, presently, the James Webb Space Telescope. Each new instrument has brought us closer to understanding Andromeda's true nature. Deciphering Andromeda's structure helps astronomers delve deeper into the universe. It serves as a benchmark for our Milky Way, offering insights into system development and evolution. The relationship between the two galaxies is crucial for understanding the fate of our own. 2 minutes and 44 seconds. The Milky Way and Andromeda are expected to collide in around 4 billion years. Recently, the James Webb Telescope has received a disturbing signal from the Andromeda Galaxy. But what does this latest signal tell us? The James Webb Telescope has provided new insights. This exceptional instrument, infinitely better than its predecessors, has captured data from Andromeda that challenges previous understandings. The telescope's robust sensors have detected unusual activity in Andromeda's center, varying significantly from past observations. 3 minutes and 15 seconds. This has intrigued scientists worldwide. The signal suggests vital processes are happening inside the galaxy, potentially linked with its massive black hole or previously concealed anomalies. One key finding is the change in Andromeda's mass. Earlier estimates suggested Andromeda was significantly larger than the Milky Way. However, new data suggests this gap may not be as vast as previously thought. Updated measurements indicate that Andromeda and the Milky Way are more comparable in size, reshaping our understanding of our own galaxy's place. Additionally, the James Webb Telescope has provided clear images and spectra from Andromeda, revealing new star formations and chemical compositions. These details are crucial for understanding how galaxies evolve and what conditions could lead to life. 4 minutes and 19 seconds. Another significant discovery involves Andromeda's active cosmic core. The data shows that the black hole at the center is more active than previously believed. This activity affects the surrounding region and may influence the galaxy's overall structure and future. The telescope's findings also touch on the mysterious dark matter. By studying the gravitational effects on Andromeda's stars, researchers can better understand how dark matter is distributed throughout the universe. This is essential to addressing one of cosmology's biggest mysteries. What is dark matter, and how does it affect the universe? These new discoveries by the James Webb Telescope have led to various studies. Scientists worldwide are analyzing the data to uncover more of Andromeda's secrets. Each finding helps piece together the galaxy's history and future, providing a clearer understanding of the universe's workings. 5 minutes and 25 seconds. Andromeda, our nearest cosmic neighbor, has a variety of unique features that interest astronomers. Firstly, Andromeda's size is significant. While estimates have changed, Recent data suggests it spans around 220,000 light-years in diameter, making it one of the largest galaxies in the local group, much larger than the Milky Way. Its immense size contributes to its mass, holding an estimated 1 trillion stars, surpassing the number in our own galaxy. 5 minutes and 58 seconds. Andromeda's structure is another point of interest. It has a typical spiral shape but with a bulging center surrounded by rings of dust and gas, sites of active star formation. These features indicate a vibrant galaxy with ongoing processes shaping its evolution. The core of Andromeda is particularly interesting due to the presence of a double-capped outflow, suggesting it may harbor a very large black hole. This is similar to the Milky Way, but Andromeda's black hole activity provides valuable insights into these cosmic objects. 6 minutes and 31 seconds. Andromeda is also surrounded by a corona of celestial material, extending hundreds of thousands of light-years. This corona includes stars, planetary nebulae, and globular clusters, offering evidence of the galaxy's complex evolution. More than 460 globular clusters have been identified in Andromeda, providing insights into the early universes. Development. Additionally, Andromeda has over 20 satellite galaxies, some of which are being tidally stripped of their stars and gas, contributing to Andromeda's growth. This process, known as galactic cannibalism, highlights the aggressive nature of galaxy evolution. The text continues with further discussion about Andromeda's future, its expected collision with the Milky Way, and the broader implications for the universe. It had been weeks since the James Webb Space Telescope, JWST, detected the mysterious signal from Andromeda, and scientists around the world were still in shock. The signal wasn't just random noise, it had structure, a repeating pattern that hinted at something more than natural cosmic activity. The question wasn't just what the signal was, but who or what was sending it. A breakthrough in the data. At NASA's Deep Space Listening Center, Dr. Evelyn Carter and her team had been analyzing the frequency modulations of the signal. It wasn't a simple radio wave or an anomaly from a black hole. It had organization, rhythm, and a complexity unlike anything recorded before. After countless sleepless nights and simulations, the breakthrough came when an intern, Jason Malik, ran the data through an advanced AI model. Dr. Carter, you need to see this. Jason's voice trembled as he pointed to the screen. The data, when plotted visually, formed a pattern, an intricate sequence that looked eerily similar to a mathematical code. The realization sent chills down their spines. This wasn't just a cosmic disturbance. It was a message. A race against time. The implications were staggering. If an intelligent civilization had been transmitting this message for over a century, why were they reaching out now? What had changed? And more importantly, what were they trying to tell us? Governments and scientific organizations scrambled to decode the transmission. The world watched anxiously as experts from SETI, NASA, and the European Space Agency collaborated in real time. The translation process was difficult, but as they pieced it together, one unsettling truth emerged. The message contained a warning. They are coming. The full translation wasn't clear, but certain symbols and patterns pointed toward an impending event, something that would reach the Milky Way sooner than expected. Whether it was a natural cosmic phenomenon, an approaching celestial object, or an unknown force, no one could say for sure. But one detail stood out in every attempt to decipher the message. The signal contained star maps, coordinates that pointed directly to the space between Andromeda and the Milky Way. A revelation on the horizon. The James Webb Space Telescope was immediately redirected to observe the region specified in the message. Days later, as new data arrived, astronomers stared at their screens in stunned silence. Something huge was moving toward the Milky Way. And it wasn't alone. The silent approach. For days, the world's top observatories focused their attention on the coordinates provided in the message. What they found was beyond comprehension. A cluster of objects, massive, structured, and clearly artificial, was moving in formation through intergalactic space. Unlike asteroids or natural cosmic debris, these objects were aligned in a way that suggested deliberate coordination. The eerie part? They weren't emitting any signals. No communication, no energy spikes, just silent motion through the void. The Galactic Council. At a top-secret meeting of global leaders and space agencies, Dr. Evelyn Carter presented her findings. A holographic display showed the incoming objects, black, monolithic shapes gliding toward the Milky Way at an alarming speed. We estimate they'll reach our galaxy's outskirts in less than 400 years, Dr. Carter explained. That may sound like a long time, but in cosmic terms, it's tomorrow. A tense silence filled the room. World leaders exchanged uncertain glances. Could this be an invasion? A migration? A warning? Then, a general from the U.S. Space Force asked the question everyone feared. What if they're already here? Hidden among the stars? Dr. Carter hesitated. She had been running a parallel investigation with data from Earth's deep space monitoring stations. What she found was disturbing. Similar silent objects, smaller but structurally identical, had been detected inside the Milky Way. Some had been stationary for centuries, hidden in deep space voids where few telescopes ever looked. Others were slowly moving, adjusting their positions as if waiting for something. The Andromeda message wasn't just a warning about the incoming fleet. It was telling us to look closer to home. A decision that could change everything. The weight of the discovery pressed on humanity like a crushing tide. If these objects were alien technology, why had they remained hidden? Were they observers? Sleepers? And when the main fleet arrived, what would they do? Governments debated their next move. Some wanted to send a message, to establish contact before it was too late. Others feared that waking a silent observer could trigger the very thing the Andromeda message was warning about. A final decision was made, a mission to investigate one of the hidden objects. The world held its breath as a deep space probe, codenamed Ares 1, was launched toward the nearest silent object drifting beyond Pluto. As Ares 1 approached, it sent back a single image before all contact was lost. A metallic structure. Symbols carved into its surface. And a single light, flickering on for the first time in recorded history.